Okay. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq Akimi bin Muhammad Baharudin. My matrix number is CB231002. So today I will present about the electromagnetism. Okay. The topic that electromagnetism gives to me is Fleming rule. First, second, Gauss law. Third, Biot-Savart law. Fourth, Faraday law, and 5 Lenz's law. Okay. For the definition of Fleming law and rule is the fundamental laws of magnetism and electromagnetic are Fleming left-hand rule and Fleming right-hand rule. They were created in the late 19th century by John Ambrose Fleming as a straightforward method of determining the direction of motion in an electric motor or the direction of electric current in an electric generator. It is significant to note that this criteria only indicate the direction of the three parameters, like a magnetic field, current, and force. When the other two parameters are known, they do not define the magnitude. Okay, next. Yeah. This is the Fleming right-hand rule. Okay, what is the Fleming right-hand rule? Right-hand rule. Okay. According to Faraday law of electromagnetic induction, when a conductor moves through a magnetic field, an electric current is induced in it. This phenomenon is the basis for the operation of many electrical devices, including generator, transformers, and motor. Okay, this is the uh, example picture for the Fleming right-hand rules. Okay. Okay, what the Fleming rules state give the state that if we arrange our thumb, forefinger, and middle finger of the right hand perpendicular to each other, then the thumbs point towards the direction of the motion of the conductor related to the magnetic field. The forefinger point toward the direction of magnetic field, and the middle finger toward the direction of the induced current. This so conclusion is for the action of the Fleming right hand rule lah. Next, that is Fleming left hand rule. What is Fleming left hand rule? A force perpendicular to the direction of the current flow and the field is experienced by a current-carrying conductor when it is put in an internal magnetic field. The direction of the force acting on a current-carrying conductor in a magnetic field can be ascertained using Fleming left-hand rule. This is for the example Fleming left-hand rule. Okay. Fleming's left-hand rule states that if we rearrange our thumb, forefinger, and middle finger of the left hand perpendicular to each other, then the thumb point toward the direction of the force experienced by the conductor. The forefinger points toward the direction of the magnetic field, and the middle finger points towards the direction of the electric current. Okay, next. The second topic is what is the Gauss law. Okay, what is the Gauss law? Gauss law according to Gauss law, the total flux linked with a closed surface is 1 per E0 times the charge enclosed by the closed. This for the formula about the Gauss law. For example, a point charge Q is placed inside a cube of the edge. Now, as per Gauss law, the flux through each phase of the cube is Q per C E0. The electric field is a basic concept of knowing about electricity. Generally, the electric field of the surface is calculated by applying Coulomb's law, but to calculate the electric field distribution is in a closed surface, we need to understand the concept of Gauss law. It explains the electric charge enclosed in a closed surface or the electric charge present in the enclosed closed surface. Okay. This is the Gauss law formula. As per the Gauss theorem, the total charge enclosed in a closed surface is proportional to the total flux enclosed by the surface. Therefore, if the flux is the symbol is the total flux and E0 is electric constant, and the total electric change is electric change Q enclosed by the surface is Q is uh, uh, to flux E0. The Gauss law formula is expressed the flux and Q per E0. There is the where Q total charge within the given space and E0 the electric constant. This is the for a Gauss law formula, and these are the simple Gauss formula. Okay, next. That is a Biot-Savart law. Okay, what is the Biot-Savart law? Biot-Savart's law is an equation that gives the magnetic field produced due to a current carrying segment. This segment is taken as a vector quantity known as the current element. Yeah, this is for the picture for the example Biot-Savart law. The direction of the magnetic field is always in a plane perpendicular to the line of element and position vector. It is given by the right-hand thumbs rule, where the thumbs point to the direction of conventional current and the other fingers show the magnetic field direction. Okay, this is the Biot-Savart law formula. Okay, this is for the example picture for the formula Savart law. Okay, consider a current carrying wire uh, symbol I in a specific direction as shown in the above figure. Take a small element of the wire of length ds. The direction of this element is along that of the current, so there is if there is that it forms a vector IDS. To know the magnetic field produced at a point to this small element, one can apply Biot-Savart law. Let the position vector of the point in a equation drawn from the current element be r, and the angle between the two be angle. Then this is for the formula Biot-Savart law. Okay, this is for example. Okay, where micro O is the permeability of free space and is equal to 4 pi multiply 10 subtract 7 tm 8 and subtract 1. Okay, next for the application of Biot-Savart law. Okay, for the application of Biot-Savart law, we can use Biot-Savart law to calculate magnetic response even at the atomic or molecular level. It is also used in aerodynamic theory to calculate the velocity induced by vortex lines. Yeah. There are three important of Biot-Savart law. Okay, firstly, Biot-Savart law is similar to Coulomb law in electrostatics. The second, the law is applicable for the very small conductors to which carry current. And thirdly, the law is applicable for symmetrical current distribution. Okay, next for the third topic. The third topic is Faraday law. Okay, Faraday law of electromagnetic induction, also known as a Faraday law, is the basic law of electromagnetism, which helps us to predict how magnetic field will interact with an electric circuit to produce an electromotive force. EMF for the symbol. This phenomenon is known as electromagnetic induction. Michael Faraday proposed the law of electromagnetic induction in the year 1831. Faraday's law, or the law of electromagnetic induction, is the observation or results of the experiments conducted by Faraday. He performed three main experiments to discover the phenomena of electromagnetic induction. There are two laws in Faraday law of electromagnetic induction. Okay, the induction of EMF is electromagnetic force in a conductor is explained by the first law, and the amount of EMF generated in the conductor is measured by the second law. So let's study this law in more detail in the next part. Okay, this is the Faraday's first law of the electromagnetic induction. Faraday and Henry conducts a lengthy series of experiments that serve as the foundation for the discovery and understanding of electromagnetic induction. Faraday deduced from the experimental findings that an electromagnetic field (EMF) is generated when there is a change in the magnetic flux across a coil over time. Consequently, the following is stated by the Faraday's first law of electromagnetic induction. Okay, next, an electromagnetic force is induced whenever a conductor is exposed to a fluctuating magnetic field. Induced current is the current that is created when the conductor circuit is closed. Okay, this is for the example, changing the magnetic field intensity a closed loop. This is experiment where the closed loop they do. Okay. There are a few methods to alter the magnetic field strength in a closed loop. Uh, Firstly, is by rotating the coil relative to the magnet. Secondly, by moving the coil into or out of the magnetic field. Thirdly, by changing the area of coil placed in the magnetic field. And lastly, by moving a magnet toward or away from the coil. Okay, next, this is Faraday's second law of the electromagnetic induction. Okay, Faraday's second law of electromagnetic induction states that the induced EMF in a coil is equal to the rate of change of a fluid linkage. The flux linkage is the product of the number of turns in the coil and the flux associated with the coil. The formula of Faraday's law is given below. That is the example for the formula of Faraday's law. Okay, where n is the number of turns, flux is the magnetic flux, and the E is the electromotive force. Okay, next, for the next topic is Lenz's law. Okay, Lenz's law is the authorized name by name after Emily Lenz. Lenz's law depends on the principle of conservation of energy and Newton's third law. It is the most convenient method to determine the direction of the induced current. What is the Lenz's law? Okay, the Lenz's law is the induced electromagnetic force with different polarities induce a current whose magnetic field opposes the change in magnetic flux through the loop in order to ensure that the original flux is maintained through the loop when current flows in. That is the Lenz's law formula. Okay. Lenz's law is reflected in the formula of Faraday's law. Here the negative sign is contributed by the Less law. The expression is EMF equal negative and bracket flat and uh, time. Okay, where is the EMF is the in this voltage, also known as electromagnetic force, and N is the number loop. This is the example for the Lens law formula. Okay, next for the Lens law application. Okay, Lens law application. They have seven application. Okay, firstly, eddy current balance. Secondly, metal detectors. Thirdly, eddy current dynamometers. Four braking system on ramp. Five AC generators. Six card readers, and lastly microphone. Okay, for the first experiment. In the first experiment, he concluded that when the current in the coil flows in the circuit, the magnetic field lines are produced. As the current flow through the coil increases, the magnetic flux will increase. The direction of the flow in this current will be such that it opposes the increase in magnetic flux. Okay, that's the second experiment. In the second experiment, he concluded that when the current carrying coil is worn on an iron rod, with its left hand behaving as an pull and is moved towards coil S, and induced current will be produced. And third experiment, in the third experiment, he concluded again that when the coil is pulled toward the magnetic flux, the coiling will decrease, which means that the area of the coil inside the magnetic field decrease. According to Lenz's law, the motion of the coil is opposed when the induced current is applied in the same direction. Okay. To produce the current, force is exerted by the magnet in the loop. To oppose the change, the current on the magnet must exert a force on the magnet. Okay. Lastly, okay, this is the example of the latest technological development significant to the law as mentioned above. Okay, ini merupakan contoh lah. Apa contoh penggunaan dengan menggunakan jenis formula yang di-mention di atas. Okay. Fleming hand rule. Okay, the rule has been used in the development of electric motors and generators. It is also used in the design of magnetic sensor and actuator. Okay, goes now for the example later technological. The law has been used in the development of capacitor, transmission lines, and the electromagnetic shield. Okay, next the biosimilar. The law have been used in the development of magnetic field sensor and magnetic field levitation train and magnetic resonance imaging (MRI). Okay, for the four is Federal law. The law has been used in the development of transformers, inductors, and generators. And the last but not least is Lenz's law. The law has been used in the development of electric motor generator and induction heater. And that's all from me. Thank you.